Hello everyone, today we are going to start our lesson number 2, IGCSE Chemistry, Atomic Structure. In the previous lecture we have discussed about atoms, that atoms, these are the smallest particle, and it is basically taken from the word atomos. Atomos is a Greek word which means unsplittable. Why this name was given to this? Because they thought they had the theory that scholars at that time, they thought that atom, the smallest particle, this is the fundamental unit and we cannot subdivide this. At that time scholars, they thought, but now due to technological advancement and due to further explorations, we can find we have now the atoms can be split. The atom can be split, or it can be divided into further subatomic particles. So atoms, it can be divided and it can be split into further subatomic particles. Subatomic particles. And now we have come to know, we have discovered, human has discovered that atom is furtherly made up of very small particles, and this is called subatomic particles. So till now the atom basically is made up of three fundamental particles. Three fundamental particles. These are: number one, electron, proton, and neutron. Is that clear? An atom is made up of these three fundamental particles. Apart from these three fundamental particles, apart from that, atom, till now, inside atom 70 different subatomic particles have been discovered. Up to now 70 different subatomic particles have been discovered, and you will discuss this in your higher classes. But these three fundamental particles, which is related to the structure of the atom, these three fundamental particles, actually why it is important, because they basically form, or basically they basically comprise or compose the structure or shape of an atom. These three particles are responsible for the structure of the atom. That's why they are called fundamental, because they actually build up the basic structure of the atom. Is that clear? So we will discuss one by one in detail that what is electron, what is proton, and what is neutron. So atomic structure, related to atomic structure, you need to keep important points. Number one, so the important points related to the structure of the atom is that an atom is made up of three fundamental particles. These are electron, proton, and neutron. These three fundamental particles are electron, proton, and neutron. An atom basically consists of nucleus and shells. Besides these three particles, the atom also consists nucleus and shells. So what is nucleus and what are shells? The nucleus is the central part. Nucleus is the central part, and inside the nucleus proton and neutron is present. It is present inside the center, and outside the nucleus shells are present, where electrons are revolving and rotating as well. This is the nucleus. Shells are present, and inside these shells electrons are revolving and rotating. Keep in mind, electron is a moving particle. It is not a static particle. It moves around the nucleus, and as well it also moves on its own axis. It also shows movement on its own axis, that is rotating. And these three particles, among these three particles, that is electron, proton, and neutron, electron is a negatively charged particle. Okay, proton is positive and neutron does not have charge, zero charge. So proton is a positive charged particle, electron is negatively charged, and neutron have no charge, zero charge. Is that clear? So these are the basic points related to the structure of the atom. Apart from these, mass of electron, proton and neutron you should also understand. Okay, so among these three particles, electron is the lightest particle. Okay, it is the lightest particle. It is very light particle. Okay, its mass is very low, and neutron is the heaviest particle. It is the heaviest particle. Okay, and proton is also heavy particle, heavier than proton. Okay, so mass of electron, okay, this proton is 1840 times heavier than electron. Okay, proton is 1840 times heavier than electron, or mass of electron is 1/1840 times lighter than proton or neutron, and mass of neutron and proton is almost equal. Okay, nearly equal, nearly same. Okay, mass of proton and neutron is same. So this is related to the mass of the electron, proton, neutron, and electron is revolving around the nucleus. This is nucleus, and inside this nucleus proton and neutron is present, and electron is not a static particle. It always revolve and rotate on its own axis around the nucleus. This is the basic concept related to the structure of the atom and the arrangement of the particles. So the particles, they are arranged in this way. Inside the nucleus, okay, inside the nucleus proton and neutron is present, and outside the nucleus shells are present. Okay, in these shells you will see electrons. They are revolving. These are electrons. Electrons are continuously revolving around the nucleus, and the proton and neutron, which is present in this nucleus, it is more heavier as compared to electron. So we can say the overall mass of the atom is concentrated, or it is being adjusted inside the nucleus. Okay, why? Because these two heavy particles, these are present inside the nucleus. So the overall mass of the atom is inside the nucleus. Is that clear? Is that clear? Overall mass of the atom is inside the nucleus, or we can say the mass of the atom is actually its nucleus, because mass of electron is actually negligible. It is very it is very low, and we will consider them as negligible if we compare this with proton and neutron. So the actual mass of the atom is the mass of the nucleus. Is that clear? The actual mass of the atom is the mass of the nucleus itself. And what particles are present inside the nucleus? These are proton and neutron. Is that clear? So mass of the electron is actually negligible. We actually neglect it because it is much lighter as compared to proton and neutron. The next important point you need to keep in mind, that size of the nucleus. Although size of the nucleus is much smaller than the size of the atom itself. Okay, although the overall mass of the atom is the mass of the nucleus itself, but the size of the nucleus is much smaller as compared to the size of the atom. So this is nucleus. Okay, we will say that I told you earlier that the overall mass is concentrated in this nucleus. Okay, inside the nucleus, the whole mass of the atom is the mass of the nucleus itself, but still its size is much smaller as compared to the overall size of the atom. Okay, in other words, I can say that, okay, I should say that most of the space of atom is empty. So inside the atom, most of the space of the atom is empty. Okay, Is that clear? So keep in mind, most of the space of the atom is empty because electrons, they are present outside the nucleus. Okay, they do not occupy the overall space of the atom. Okay, so this particles, proton and neutron, they are being closely packed inside the nucleus. Okay, is that clear? So this was the reason, this was being proven by the Rutherford. Okay, this was being proven by Rutherford experiment. He was an English scientist and he proved that most of the space inside atom is empty. Okay, he did an experiment through by bombarding a gold foil. Okay, he bombarded a gold foil through the atom. Okay, through alpha particles, through rays. This rays, the name of this ray was alpha particle. Okay, it's a type of radioactive rays, and it is actually helium nuclei +2 charge. Okay, helium nuclei, and he bombarded this gold foil with this alpha ray, and what happened, he observed that most of the rays passes through the atoms of the gold without showing any sort of deflection. So he concluded that most of the space of the atoms, it is free. Why? Because the rays passed through the atoms of the gold without showing any sort of deflection. Nearly 80% rays of alpha rays, they passed through the atoms without any deflection. They passed straight through the atoms without showing any sort of deflection, either towards positive pole or either towards negative pole. Why? Because most of the space inside atom is free. It is not being fulfilled by these three fundamental particles. Is that clear? So this was the experiment of Rutherford, and he was a British scientist. So the next important point related to this structure of the atom is that I told you earlier that this electron is a positive charged particle and proton is negative and neutron is neutral. So there is a force of attraction. We know that negative charge and positive charge attract each other. So there is force of attraction between electron and proton. Why force of attraction? Because both charges, they are oppositely charged. Okay, both are oppositely charged particles, and we know that oppositely charged particles attract each other, and because of this structure, because of this attraction, the atom maintains its shape or structure. The atom maintains its structure because of this force of attraction between oppositely charged electron and proton. Is that clear? Neutron is present in the nucleus as well. So this is how the concept related to force of attraction. Force of attraction between electron and proton. Why force of attraction? Because both are oppositely charged particles. They will attract each other. As a result, the atom as a whole will maintain its shape. The other important point related to the structure of the atom is that keep in mind that number of electrons, these are always equal to the number of protons in an atom. Okay, if an atom consists of 2 electrons, that atom must consist 2 protons as well. If an atom have 5 electrons, that atom must consist 5 protons as well. If an atom consists of 100 electrons, that atom must consist 100 proton as well. Okay, but the number of neutrons, it varies. Okay, it is not specific. So the number of a neutron does not depend on electron number or proton number. Is that clear? The number of neutron, it is independent. It does not depend upon the number of electron or proton. Why? Because it is a neutral particle. It is a neutral particle. Is that clear? So this is about the number of proton and electron. Okay. So this was the concept. Now keep in mind that nucleus. Okay, the nucleus. If a nucleus, the other important point. Okay, nucleus is a positively charged as a whole. It's a positively charged particle of the it's positively charged. Okay, why positively charged? Because we know that inside nucleus proton and neutron is present. Okay, so because of the presence of proton inside the nucleus always carries positive charge. Is that clear? And the charge of atom is neutral as a whole. Okay, why charge of atoms? They are neutral because the number of electron is always equal to the number of proton. These will cancel each other effect, and the remaining charge will be 0. Is that clear? Next important point related to the atom. You also learned about ion. What are ions? Okay, you may have studied in your previous classes as well, but let me remind you that ions. Okay, ions. If an electron is removed, okay, from an atom, or if an electron is being added to an atom, okay, that atom is converted into ion. Okay, for example, this is an atom. For example, this is an atom. If this electron, okay, if this electron is being removed from the atom, what will happen? What will happen that this electron will have 2 proton, because number of electron and proton are always equal. Neutron may be present, so this atom will convert into positive charge ion. Okay, so we can convert an atom into an ion if we remove an electron, okay, or if we add electron. If we remove electron, what will happen? That the positive charge will get increased and the negative charge will get decreased. As a result, the atom will change into positive ion. Okay, and if we add electron to an atom, the number of negative charge, it will get increased as compared to the number of positive charge. Okay, so what will happen? That the overall atom will change into negative ion. So the definition of ions is any charged atom. Okay, how an atom is being charged? If we add electron or if we remove electron. This is the basic difference between atom and ions. Okay, so the next important thing students get confused about this is that is about atomic number, okay, and mass number. Okay, atomic number is the number of electron or proton within an atom. Is that clear? So the number of electron or proton is called an atom. We cannot define atomic number as number of electrons or and. Don't use and, because the number of electron and proton will get added. We do not need to add a number of electron or proton. We will just say the number of electron or proton. Most specifically, we consider, okay, most of the time we consider proton number as atomic number. Why we consider proton number as atomic number? Because protons do not take part in any chemical reaction. Okay, because protons do not take part in chemical reaction, while electrons take part in chemical reactions. So their number remains specific. Numbers of proton always remain fixed, always remain specific. Their number is not going to change at any condition. The number of proton does not change, it remains inside the nucleus. Okay, this is atom, this is nucleus. So the proton will reside closely bounded with neutron inside the nucleus. So the number of proton is not going to change. So most of the time we consider atomic number as proton number of the atoms, and it is being denoted by the letter Z. Okay, symbol, this is being denoted by the symbol Z. Okay, next important topic is about mass number. Mass number, it can be defined as total number of proton and neutron. Okay, so if we add number of proton and neutron, it is equal to mass number. It is denoted by A. Is that clear? So this is the important thing that you need to keep in mind. Okay, so very important theory, that Dalton's atomic theory. It's very important. It's based on the atomic structure. After doing many experiments and research, Dalton, who was a scientist, he proposed the atomic theory, and he says that a pure element is composed of atoms. Okay, an element is made up of atoms. The atoms of each element are different in size and mass. Okay, the atoms of each element, they are different in size and mass. For example, the element of the atoms of the hydrogen element. Okay, if we compare this with the carbon. Okay, carbon atoms of the carbon element, these are heavier as compared to hydrogen. Okay, hydrogen is the lightest atom. It is the lightest known atom. So if we compare carbon with gold, symbol having Au, the atoms of the gold will have greater mass as compared to the carbon. So we will say that carbon is lighter, carbon atoms are lighter as compared to gold. So each element, atoms of each element, they are different in size and mass. Okay, an atom is the smallest particle that take part in a chemical reaction. The chemical reaction occurs because the atoms, they take part in they combine together. Okay, so atom is the smallest particle that take part in a chemical reaction. And I told you that how they do take part in chemical reaction. If atoms, they give and take electrons, okay, they take part in chemical reaction. If they transfer electrons, through transferring electrons between atoms, this is one way of chemical reaction. Okay, or if they share the electrons. Okay, so through sharing electrons or through transfer of electrons, the atoms take part in a chemical reaction, and as a result, compounds or molecules are formed. So atoms of different elements can combine together to form molecules and compounds. Okay, the molecules are formed as a result of covalent or sharing of electron, or the compounds are formed either through transfer of electrons between atoms or through sharing of electrons between atoms. Is that clear? So this is the basic theory related to the structure of the atom. So this was all the concept related to the structure of the atom. Keep in mind that most of the space of the atom is empty. The positive charge, they are attracted towards the negative charge electron, and electron, as a result, they are attracted towards the positive charge proton. Okay, and chemical reaction, electron only take part. Okay, the atom, they take part in a chemical reaction, obviously, but which fundamental particle, which subatomic particle of the atom take part in chemical reaction? That is only electron. Is that clear? Electron either being transferred between atoms or the atoms, they share electron. Is that clear? So this is the overall concept related to the structure of the atom. I hope that you have understood the concept.